Do you know how you can convert a galvanometer to an ammeter? Simply by connecting a low resistance wire called shunt in parallel with the galvanometer. And also, this same galvanometer can be converted to a voltmeter simply by connecting a high resistance wire called multiplier in series with the galvanometer. Now in this video, I'm going to guide you through most likely questions you are going to see on galvanometer conversions. With no further ado, let's get right into the video. An ammeter of resistance 5 ohms has a full-scale deflection when a current of 50 milliamperes flows in it. The value of the resistor required to adapt it to measure a current of 5 amperes is what? Option A, 19.8 ohms. Option B, 5.00 ohms. Option C, 0.05 ohms. Option D, 0.25 ohms. Now, for us to solve this question, let us take the parameters quickly. So let's go. We have the ammeter of resistance 5 ohm, that is the resistance of the galvanometer. So Rg is equals to 5 ohms. The current that flows through the galvanometer is 50 milliamperes, that is, current of galvanometer is 50 milliamperes. You know what milli means? This is 50 times 0.001 amperes, which will give rise to 0.05 amperes. That is the current of the galvanometer. Now, the value of the resistor required to measure a current of 5 amperes. In this circuit, the current that flows is 5 amperes. So let's go. The total current that flows is 5 amperes. So we are looking for the resistance of the shunt. But we don't even know the current of the shunt. So we can get the current of the shunt using this. Now the current of the shunt is equals to the current flowing through the circuit minus the current of the galvanometer. Simply by saying the current flowing through the circuit is 5 amperes minus 0.05. Okay, now this is going to give us 4.95 amperes. This is the current of the shunt. The formula to this question is PD across shunt is equal to PD across galvanometer. Okay, now what is PD? PD is from Ohm's law, V is equal to IR. So we have current of the shunt, resistance of the shunt is equal to what? Current of the galvanometer, resistance of the galvanometer. Is that clear? Now let's substitute into what we have to get our answer. Current of the shunt is 4.95. Whereas you're looking for the resistance of the shunt, that is Rx, is equals to current of the galvanometer is what? 0.05 multiplied by the resistance of the galvanometer is what? 5. So let's go. 4.95 Rx is equals to 0.25, right? So divide both sides by the coefficient of Rx, which is 4.95. Okay, now we cancel. My Rx is going to give us, when we divide, 0.05 ohms. Do we understand what I just did? Okay, now in this question, what I did was that the current flowing through this particular circuit, you have to subtract it from the one flowing through the galvanometer. So the rest will now move to the shunt. That is the only way this ammeter, which is the galvanometer, can start measuring what? In ammeter. Now from what we have gotten so far, the correct option to this question is option C. A galvanometer with full-scale deflection of 10 milliamperes is to be converted to a voltmeter with full-scale deflection of 5 volts. If a series resistance of 498 ohms is used for the conversion, the resistance of the galvanometer is what? Option A, 2 ohms. Option B, 10 ohms. Option C, 5 ohms. Option D, 1 ohms. In this question, we are trying to convert a galvanometer to a voltmeter, and we are going to use a high resistance wire called multiplier, which must be connected in series with the galvanometer. Okay, in this type of circuit, the same current flows. Any current that flows through the galvanometer flows through the multiplier. Hope that is clear. Alright, so let's go. By setting our parameters, we have that the current of the galvanometer is 10 milliamperes. That is, Ig is equals to 10 milliamperes. You already know what is milli, right? Now this is 10 times 0.001, okay? Which will give me 0.01 amperes. Is that clear? Now from the question, we have the PD, the V of what? 5 volts, okay? Now the resistance of the multiplier is 498 ohms, right? And remember that it is the same current that flows through this circuit, okay? The same current that is dictated in the galvanometer is also dictated in the multiplier. So let's go. We say that Im is equal to what? 0.01 amperes. So let's solve. Our formula is, what are we actually looking for? We're looking for the resistance of the galvanometer. Our formula is the V is equals to PD across multiplier plus PD across what? Galvanometer. Now let's break it down to say that V is equals to Im Rm plus Ig Rg. Is that clear? And the total V across the circuit is what? 5, which is equals to the current of the multiplier is 0.01, okay? The resistance of the multiplier is multiplied by 498, okay? Now this is equal to the current of the galvanometer is what? 0.01 multiplied by R what? G. Is that clear? Let's go. You say this is 5 is equals to, this multiplied by this is going to give us 4.98, right? Then plus 0.01 Rg, okay? Now if you take this one to the other side, you're going to change by saying this is 5 minus 4.98 is equal to 0.01 Rg. Is that clear? Now if you subtract, you're going to get what? That this is what? 0.02 is equals to 0.01 Rg. Now let's divide both sides by the coefficient of Rg. This cancels this. I have that Rg is equal to 0.02 over 0.01, which is going to give me what? My Rg is equal to 2 ohms. All that is clear. Now look at the way I took my time to solve this problem. So in case you see it in this your first comment JAMB, you must not make mistake. I hope that is clear. Now from what you have gotten so far, the correct option is option A. And don't forget, when you are converting a galvanometer to a voltmeter, you must connect in series, okay? And it must connect a high resistance wire in series with the galvanometer, and the same current flows. Any current that is measured in the galvanometer is going to flow through the multiplier. Is that clear? If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for the same forthcoming exam can go through it and learn from there. I will see you next time in the next one. Bye for now.